So there's only two real skills you're going to need in order to do well on this quiz. The first is determining the number of outcomes that are available given a certain set of criteria. For example, if I were to flip 3 different coins, how many outcomes might there be? There are 2 primary ways of doing this. The first way is with a decision tree. So after my first coin, I would have heads or tails. After my second coin, I would have heads or tails again. And after my third coin, I would have heads or tails for the last time. Heads, tails, heads, tails, and heads, tails. And so now I can count the number of outcomes there are. There is all heads, that's 1, 2, 3, 4, 5, 6, 7, 8. So I know there's 8 total outcomes. Now, how many of those outcomes have, let's say, 2 heads? Well, this one has 3 heads. This one has 2 heads, there and there. This one has 2 heads, that one does not. 2 heads, 2 tails, and then 2 tails, and then 3 tails. So really, one of the skills you need is to be able to do this, determine the number of outcomes. Now, that's not the only thing I want in terms of that skill. I also want you just to be able to look at each one and decide, well, how many choices are there? If you just multiply those together, you're going to get the number of outcomes. So how many choices do I have for my first coin? Well, I can flip a head or a tail, so it's 2 choices. How many do I have for my second? It's the same thing. It looks like I have 4 choices here, but really I don't. I don't have 4 choices here. I have 2 choices for after what the first flip, and I have 2 choices after the first flip. So which path it follows is determined by what was flipped previously. But the number of choices I have for a coin is always the same. It's going to be heads and tails. I have 2. And it's going to be the same for the third. When I multiply those together, it's going to give me 8 total outcomes. So you should be able to do this and this. That being said, there's going to be times where it's not just 2 times 2 times 2. For example, let's say I want you to pull cards out of a deck of cards. So a deck of cards has 52 cards normally. How many combinations would there be if I was going to pull, say, 5 cards out? Well, I would look for each position of 5, right? First card, second card, third card, fourth card, and fifth card. Well, how many choices do I have for my first card? Well, I have all 52. How many do I have for my second card? I don't just 52, 52, 52, 52 because that is not true. What's happening here is actually I have 1 less because I've pulled 1 card and put it here. So now I have 51. And then when I get to my third card, I've already pulled 2. That leaves 50 left. And then 49 and 48. Now, I multiply those together, and that's going to give me the number of 5 card permutations, number of 5 card options I have for my deck. Now, if I do this, the times, I am assuming that order matters. And what I mean by that is that, let's say I had ace, 2, 3, 4, and 5 of spades, and those are the cards I picked. Sorry, I'm going to make it hearts because it's easier to draw. If I had pulled these 5 cards, I'm assuming that order matters when I do it this way, which means that ace 2, 3, 4, 5 is different than ace 3, 2, 4, 5. This would be counted as a separate way of doing it. This would be a separate answer. So when I was looking at the flipping coins, I had 8 answers. And if you think about that again, there was heads, heads, heads. Heads, heads, tails. And then there was heads, tails, heads. And heads, tails, tails. If you look at this, I said there's 8 possible outcomes. So let me do the same tails, tails, tails. Tails, tails, heads. Tails, heads, tails, and tails, heads, heads. Right? These are the 8 possibilities. But if you notice, this has 2 heads. This has 2 heads. This has 2 heads. So some people will be like, well, this, and this is the same. But they, in this case, in the example we're looking at, are not the same because order actually matters. So that's all you're expected to be able to do is figure out the number of outcomes where your order is like this, where if the order is changed, like it is here and here, even if the result is the same, if the order is changed, it counts as a different outcome. Super duper level 4 kids. So, super duper duper level 4 kids, they're going to go out of their way to try and figure out how many sets you'd have, how many permutations you'd have if the order did not matter. Where if 1, 2, and 3, and 3, 2, and 1, and 1, 3, and 2 are all count as the same because it's the same 3 numbers. So I'm going to give you an example. Let's say we have the numbers 1, 2, 3, 4, and 5. And I'm asking you to pick a team of 3 and put it on there, and those are the names. 1, 2, 3, 4, and 5. Now you could pick all sorts of different things. You could pick 1, 2, and 3. You could pick 1, 2, and 4. You could pick 1, 2, and 5. You could pick 2, 3, and 4, 2, 3, and 5. You pick 3, 4, and 5. So it seems like, really, if you think about it, we could have a lot of different answers here. Because some people might think, well, I have 5 choices for my first number, which is true. I have 4 choices for my second number, which is also true. I have 3 choices for my third number, and so that's 60 altogether. Shh, Jonah. Then, if you look at it this way, it seems like I have 60 team choices here, but I really don't. Because, if you think about it, a team that has number 1, 2, and 3 on it is the same as a team that has 3, 2, and 1 on it, is the same as a team that has 2, 1, and 3 on it, is the same as a team that has 2, 3, and 1 on it, is the same as a team that has 3, 1, and 2 on it, is the same as a team that has 1, 3, and 2. So, if you think about it, for each team of 3 that I pick, there are 6 different orders they could be put in. And this counts all of those as different, which means I'd really have to divide that 60 by 6 to figure out how many different teams I could have. This says I could have 10. And if you think about it, that makes sense. I could have a 1, a 2, and a 3. I could have a 1, a 2, and a 4. I could have a 1, a 2, and a 5. I could have a 1, a 3, and a 4. I could have a 1, a 3, and a 5. I could have a 1, a 4, and a 5. Now that takes care of all of the teams that have 1 on them. So then I could have a 2, a 3, and a 4. I could have a 2, a 3, and a 5. I could have a 2, a 4, and a 5. That takes care of all of the additional teams that have 2 on them. Because I have these ones already that have 2. Then I could have a 3, a 4, and a 5. And that would actually be the last one. I wouldn't have any teams that start with 4 or start with 5 because they're already spoken for here and here and here and here and here and here. Because again, order doesn't matter. It's just who's on the team, not what order they're on the team. And so again, to kind of sum up, if I want to figure out how many there are on a team, and again, this is only super level 4, how many people, or how many different ways I can pick a team, say 1, 2, 3, 4, and 5, I ask myself, I do it the same way I would before. How many choices do I have for the first one? 5. How many for the second? 4. How many for the third? 3. And I would multiply those together. And I would divide this number by how many ways might that team of 3 be ordered? How many ways, let's say I picked Billy, Susie, and John. How many ways might they be ordered? Well, let's look at that team again. If I know it's Billy, Susie, and John, how many choices do I have first? I have all 3 of them. How many choices do I have second? The last 2. How many choices do I have last? Whoever's left over. That's going to give me 6. And then I would just divide these 2 numbers to get my 10 total different teams I could have picked. So, hopefully that helps you guys out. I'm going to do one more quick example. Let's say we're looking at a situation in which we have 10 different letters. A, B, C, D, E, F, G, H, I, and J. And I just need to figure out how many 2-letter combinations I can make. I would ask myself, how many choices do I have for my first letter? I have 10. How many choices do I have for my second letter? I have 9. I multiply those together and I would have 90 different 2-letter combinations. A, B, A, C, A, D, A, E, A, F, A, G, A, H, A, I, A, J, and so on. This 90, remember, treats AB as if it is different from BA. And that's the way all of the questions pretty much are going to be phrased except for the Super Duper Level 4. Super Duper Level 4 might say, you know what, order does not matter. So then you'd have to ask yourself, well, how many letter combinations are there now? Well, you'd ask, if I have 2 letters, how many ways could I rearrange those? I could have 2 choices for the first, 1 choice for the second, and so I would have to divide the 90 by 2. That's going to equal 45. So there are 90 total ways to pick 2 letters. But there are 45 total ways to pick 2 letters if the order doesn't matter of the letters I picked. So hopefully that helps you with that part. And then look at the simulations video as well, and then we'll talk about it tomorrow before you quiz.